Hello, my name is Jeff Atkins. I am a research biologist with the U.S. Forest Service, and I'm going to walk you through an example on using R for remote sensing applications, particularly with lidar, from an example here in a paper that myself, Atticus Stovall, and Carlos Silva put out in Forest Ecology and Management last year, open source tools in R for forestry and forest ecology. So specifically within this paper, I'm going to be focusing on how to go from raw lidar data to this guy right here, using an example data set at the Blandy Experimental Farm, which is it's a field station up in northern Virginia that includes a lot of fields, agricultural fields that were allowed to go fallow, and some were resulted in forest regeneration. In this case, the one we're particularly going to be looking at is a forest successional gradient moving from just about 20 years abandoned here on the right, where you see the lowest canopy. These colors correspond to the canopy height in meters, and then up to a little bit over 100 years old here in this canopy that's getting close to 40 meters. You can see this nice little thing. And then here we have this little transect that is a slice taken out of this area, where you can see again, here's the younger forest here, then the kind of middle succession forest, about I think somewhere 40 to 60 years old, and then this forest over here that's a little bit over 100. It's again that area on the right. So we're going to walk through how to get from the raw lidar data to this kind of finished product here. So these are written in R, these examples, and they're written in a code that's called R Markdown, which is very similar to regular R code. It's just R code that when you're all done, it will format a nice, pretty little document. But what I'm going to do is we're going to take these snippets from this document, and then because the finished product looks, actually, let me show you the finished product first so you know where we're going. This is the remote sensing one. So this is the actual kind of walkthrough step-by-step process that I'll go through today of how to use it, particularly the R package lidar and forest gap R. Or maybe forest gapper, I don't know. But so this will be a finished product here. This is kind of the step-by-step thing that we're going to walk through. As you can see, there's a few steps getting from that raw point cloud to that finished product. We're going to walk through them real quick here, if my computer can handle it today. So first we're going to start off with our new script here, and we're going to say this is our Blandy Experimental Farm lidar demo script. I like to make little headers on my scripts for the most part that kind of convey the information, author by Atkins, and then put in my email. It's good that you can share your R code, and that's great, but it's also good to have kind of some provenance, right? And kind of who did that and whatnot. So one thing that we need to do in R, and this is what actually makes R a pretty powerful little software coding platform, I think, is the ability to use packages. So this, we're going to copy the packages that we need out of here, and we're going to put them in here. So I'm going to say this is our required packages area. So in R, when you put in the little hashtag or pound sign, that is a commenting character. And that means that R, when you go to run this code, meaning you kind of tell it to go do what you want it to do, it's not going to run that. It's going to ignore that. The comments are to help interpret the code. Commenting is really good because maybe you're not going to share your code, but there's a decent chance that you're going to need to look back at this later at some point, maybe 1 year, 5 years, and you may not have any idea what the heck you were doing if you don't adequately comment that code. So I like to comment a lot. One other thing that I like to do in code, as you'll see, is I like to put a lot of spaces so that I try to make my code readable as well to the human eye. And I find that kind of being jumbled up can be a little bit difficult. So this is requiring a few packages here that we need. We require, what do we actually need for this? Okay, so the only ones that, this kind of code right here, this is done where it says if require lidar, install packages lidar, and then call, and this is actually the call, the library lidar is actually the thing that brings it into our workspace. Okay, so I'm going to assume that you're working from a very fresh, kind of environment, and you don't have anything that you're needing to do on that, right? So, you're starting from scratch. This is like what this would do is this would like look at the computer and be like, does it already have lidar? If not, I need to install it. That's what the exclamation point means. Like if you say this requires the lidar package, it's not there, I need to install it. So if you didn't have the package, what you would want to do is you would actually just want to run this code over in your console. Just install packages. I already have it, so I don't need to go through all of this process. Not a big deal. But we're going to go through one just to kind of example. So as you see, like this is what it'll look like when you kind of load in a new package that you haven't installed. You have to kind of go through this procedure. But the trimmed down version of this is what we really need. We need just that. We are not going to need dev tools for this one, are we? We are going to need dev tools for this. But you need the SF package, which is a package used for working with shapefiles. We use the ggplot package, which is a package that has to do with plotting, and it's a really good way to plot. ForestGapR is a developmental package, and so if you're going to install this one, the current version, or at least the version that I used on this one, I don't know if it's been updated in CRAN. Actually, I guess we can check with Carlos. Actually, it would be to see. Well, let's just actually see. Let's do install packages, and then capitalization matters, as does spelling. So it looks like it is. Do you want to restore R prior to install? No. Cool. Okay, so it's good. Sometimes you work with packages, because I have a couple packages that I've made that aren't necessarily ready for prime time. So they're not, installed directly from like a big directory. When you're running this install packages, you're pulling from what's called CRAN, which is the Composite R Archival Network. I think I got that right. And what that is that's a series of curated packages and code that have been really well tested and are going to run on your computer as long as you have the up-to-date version of R, piece of cake. Now, there are other packages, and like I said, like I have a couple of these where maybe they haven't passed all the necessary tests or whatnot, or there's something that's, maybe they're too large and they're not actually on CRAN, or maybe they're just developmental. There's another lidar package called the Canopy Laser package that works really well with lidar, but it's not on CRAN, and so you have to install it using this process of going to a GitHub repository. GitHub's a website that holds code. You can actually see, like this is my GitHub page. So this is the GitHub page for the forest analysis and R package that we had for this paper. I could actually, so you could install this. As you can see, we also have this. This is not on CRAN, and so to install this, you have to run using the DevTools package, install GitHub. Against, that's my GitHub repo name, and then that, and it'll install the package. Okay, so we got all this. All right, so we're working with ggplot. We have the ForestGap package. We have the raster package, which is a package that allows us to work with geospatial raster layers. And then something that I like is a package called Veritas, which is a color palette package that has a lot of color palettes that are easier for folks to read if they have some type of color blindness or something. So it works really well. Okay, so we run all these. Okay, seems to be good. Okay, now we're going to save this file. Let's just start this first. I'm just going to save it here. This is going to be a test file, test blandy lidar.r. Cool. And I spelled blandy wrong. That's all good. Okay, so let's get to the meat of what we need to do here. Now, so the raw lidar point clouds, that they often come in what are called a LAS file format. And so that's what lidar works with really well. So first, let's copy these two pieces of code here into our thing. So now, this little indentation here, you'll see it's in the this is telling it where my raw lidar file is. And my raw lidar file, because I saved in my directory over here, it's in an external data